Hello, I'm Chris James. This video will demonstrate the waveforms and output levels of the Hushe A-CES using a pair of light-emitting diodes, or LEDs, in place of the user. The Hushe A-CES generates a very low current output, which is barely sufficient to light a standard LED. For this reason, I'm using two low-power 3mm LEDs for this demonstration. A circuit diagram is provided in case you're interested. As you can see, I've connected a demonstration circuit to the electrode jack socket on the Hushe A-CES, and the lighting shown by the LEDs should give you an idea of the low currents involved, together with an indication of the shape of the waveforms. The first waveform that I'll be demonstrating is a 0.5 Hz square split wave. I set the A-CES running at level 1. And as you can see, the LEDs barely show any lighting at all. If we move up to, say, level 3 or so, you may begin to notice the on-off pattern of the square wave showing in the LEDs. At around level 5, the effect is greater. And you can notice how the waveform is split with a gap after each pulse, separating them from each other. Later on I'll demonstrate a joined waveform to show the difference. At level 10, the effect is greatest, which clearly shows the square wave with a 50% duty cycle, because half of the time is spent with no lighting. There it is. In this second demonstration, I'll set the Hushe A-CES to generate a split sine wave at 0.5 Hz, which should show up as a sequence of smooth pulses. Again, at level 1, the effect's very small and the LEDs can barely be seen to light up at all. At level 3, you may just be able to pick out the smooth pulses in the waveform. If we go up to level 5, the effect's understandably a bit greater, as there's a bit more current being sent through the LEDs. And at maximum level, the effects can be clearly seen. With smooth sinusoidal pulses oscillating from the left to the right ear in the demonstration. In this third demonstration, I'll set the Hushe A-CES to generate a split triangle wave at 0.5 Hz. Triangle waves are less energetic than the square and sine waves, as can be seen from the dimmer lighting of the LEDs. Again, at level 1, the effect was very small and the LEDs can barely be seen to light up at all. At around level 4, there's just about a noticeable swell to the waveform. Just about see it there. And if we go up to level 10, then the waveform should be clearly visible, and it's similar to the sine wave but a little bit less energetic. The LEDs don't quite light up as rapidly. In this fourth demonstration, I'll set the Hushe A-CES to generate a square joined waveform. This should show you how the split and joined waveforms are different. And when the level's high enough to make itself visible via the LEDs, you should be able to see how the two pulses happen with no gap in between, and then a gap where there's nothing happening. So they happen next to each other and then there's a gap. This is a joined waveform. If you recall, the split waveform had a gap both before and after each pulse. They were evenly spread. Raising it up to level 10 so it's most visible. Now you can clearly see join type waveform. Half of the time it's active with either one or the other on, and half the time it's off with nothing happening. Next, I'm going to reduce the duty cycle from 50% to 20%. This should result in a longer off period, which will show up as shorter flashes from the LEDs. Increasing the level so it's visible. So there you can see the shorter flashes from the LEDs and a longer period of no activity. Again with the joined waveform. I'm now switching to the square split type waveform. Just to remind you of the more balanced nature of the split waveforms. So around level 7, level 8 there. And the split waveforms are evenly balanced with an on-off, on-off shape to them. Reducing the duty cycle to the lowest setting of 10% results in the shortest available pulses. Again, raising the level up quite high so it's visible. Now we have very short pulses at 10% duty cycle. 90% of the time nothing's happening. That's what 10% duty cycle means. And if we then go up to the maximum duty cycle available on this device of 60%, that means 60% of the time there's energy transferring either from the left or from the right. 40% of the time nothing's happening. So we put the level up so it's visible. And there you go. In this fifth demonstration, I'll set the Hushe A-CES to use a higher frequency of 50 Hz. There are three frequencies available on the device, 50, 100 and 0.5 Hz. We'll use a square split wave. At level 1, there's no noticeable lighting of the LEDs. At a higher level, if we go up to level 5 or so, I think we may have to turn off the light for a moment. You can just about see a uniform glow from each LED. This is a result of each LED rapidly being turned on and off about 50 times a second with a 50% duty cycle. If we go up to the maximum level, the effect should be most noticeable. That was using a square split wave, which is the most energetic waveform. Now I'll set the Hushe A-CES to use a triangle split wave, which is the least energetic shape. And again at level 1 you can't really see much at all. Even at level 5 this time, it's quite difficult to make out much of a glow due to the lower energy of the waveform. Now we're at the level 10. And as you can see, it's only really at the higher levels that the triangle wave's capable of being visualized in this setup, all because of the amount of energy delivered by a triangle wave is half that of the square wave. In this final demonstration, I'll set the Hushe A-CES to use the highest frequency of 100 Hz using a square joined waveform and a 60% duty cycle. So at level 1, there's nothing much to see as usual. There is something going on there, but the LEDs aren't capable of showing it. At level 5, the LEDs probably show a bit. Just a bit of a glow there, representing the rapid on-off signals about 100 times a second. And at maximum level the brightness is a bit greater, as would be expected. I'm now changing the waveform to a sine joined type, which should result in less energy and a dimmer glow in the LEDs. At level 1 there's nothing much to see again. Excuse me. Level 5 the LEDs are glowing, but less than they were with the square wave. And at maximum level the LEDs are glowing brighter, but not so bright as they were with the square wave. Now I'm going to set the Hushe A-CES to use a triangle joined wave at 100 Hz again. This is the least energetic of the waveform shapes, the square, sine and triangle shapes. Level 1, nothing much to see again. And this time at level 5 there isn't much to see either. Excuse me. And with the triangle wave only at high levels, do you notice any real effects on the LEDs? So that concludes this demonstration video, which was hopefully informative for you for the different waveforms available on the Hushe A-CES. If you've never used the device, then I hope you've been able to get a basic understanding of how it works and the slight sensations that you may experience when using the device by analogy with the way in which the LEDs glowed. When you do use the device, you shouldn't go above what's comfortable for you. As a general guide, it's best to increase the level until you notice some tingling sensations in your earlobes and then reduce the level by 1. If you experience sensations at level 1, just stay at that level for a while and the sensations will usually disappear after a few minutes. Please visit www.cranialelectrotherapy.co.uk for more information or to purchase the Hushe A-CES cranial electrotherapy stimulator. I'm Chris James, and thank you for watching.